Okay, in this video we're going to start 13.4, which is the last section that we're going to do in chapter 13. It says that a loan for a substantial amount extending over a long period of time for the purpose of buying a house or other property is called a mortgage. To amortize a loan means to break down gradually the amount of money that you owe back on the loan. Assume monthly payments when amortizing a loan. Okay, so we got a closed-end credit problem. We talked about closed-end credit and open-end credit in section 13.2. So basically the amount that you're going to be paying each month is going to be the same. Okay. The regular monthly payment, denoted by R, to repay a loan of P dollars over a term of T years at an annual interest rate, is given by this formula. Okay. And we're going to be using this formula here in this worksheet. So problem 21 says that the Ulrich family plans to buy a home for $174,900 and has been offered a 30-year mortgage with a rate of 4.5% if they make a 20% down payment. Okay, so part A, what will the monthly payment be with this loan? Okay, so let's be clever. If the down payment is 20%, then the amount financed will be the remaining 80% of the selling price. Okay, so the amount that they're going to finance is 80% of $174,900, which is $139 and or $139,000 $920. So that's going to be our principal value. Okay, and to find the monthly payment, I'm going to use this formula up top. Okay, and so the $139,920 is my p-value. R is 4.5%. Okay, so 0.045 divided by 12 times 1 plus 0.045 divided by 12 to the power of 12 times t is 30. So this is a 30-year mortgage divided by the same number minus 1. Okay, now the reason why I've got this circled here is because I usually have it so that we can type what I have circled into the calculator first, since this is only going to differ by 1. By the way, 12 times 30 is 360. Okay, so I'll just take note of that. Okay, so 1 plus 0.045 divided by 12 to the power 360. Okay, now I know that I'm going to divide by 1 less than that number that I just read you. So the 3.84769805. Okay, so I'm going to divide by 2.84769805. And here's the number that I'm looking at so far. That's all the circled information there. Okay, and then I'm going to multiply by the rest of the uncircled information up top there. Okay, so times 139,920 times 0.045 divided by 12. Okay, and I get $708.95. Okay, as the value. Okay, and that's what the Ulrich family will be paying every single month for the next 30 years. And that's a closed-end credit problem, so the amount won't change. Now, there's a way that you can get this quicker than using a formula, and that's by using this table here. So because the percentage and the term of the mortgage, 30 years, are both listed, so here's 4.5%, here's 30 years. I'm going to match up that row and column to get 5.06685. Okay, and there's that number, 5.06685. Now, what I do, and since this is the monthly payments to repay principal and interest on a $1,000 mortgage, we don't have a $1,000 mortgage. We got a $139,920 mortgage. Okay, so I divide that by 1,000, and I end up getting exactly the same number. Okay, so check it out here. If I should show you, 5.06685 times 139,920 divided by 1,000. Okay, yeah, so I end up getting exactly the same number there. Okay, and it's $708.95. Okay, now the nice thing about the table is that it's available, and it's obviously quicker to use the table. Although, you see, from the table, if I have a rate that's not listed or a term of the mortgage that's not listed, I can't use this table then. Okay, and I'm going to be forced to use the formula. So knowing the formula actually is important. Okay, sometimes our only option is to use that. Part B. Find the total amount of interest the Albrecht family will pay if they take the loan. Okay, so the number of payments that they're making is 30 times 12 months in a year. Okay, so there's going to be 360 payments of this amount here, the $708.95. So if I multiply those two numbers together, I get $255,222. Okay, and now the house is currently they owe $139,920 on that, and so if I subtract those two amounts, that gives me a difference of $115,302. Okay, and I got a note there saying this looks like a typo, but in fact it's not any typo. Okay, that's typical for somebody to owe this amount extra on a house. Okay, so we're going to see in a short while here that a huge amount of the interest happens early on in a loan, and gradually goes down to zero. Okay, so there's a definition there. An amortization schedule shows the breakdown of payments for interest and principal, and the principal balance for each month over the entire life of the loan. Okay, problem 22 says to use the table below to calculate the first 2 months of an amortization schedule. Okay, so again, there's 360 payments that this family is making. We're just going to look at what are the first 2 payments going to look like? Okay, so payment 1 and payment 2. Now, the rate is $124,750, and the interest rate is 6.5%. The term of the loan is 25 years. Okay, so if I use the formula for R, okay, 12 times 25 gives me a power of 300. Okay, so I'm going to say 1 plus 0.065 divided by 12, and that's to the power of 300. Okay, and I'm going to divide by 1 less than that number. Okay, so divided by 4.056197844. Use all the digits that you see there. Okay, and so here's the number I'm looking at, and I multiply by the rest of the information here in the numerator. This 124,000, so times $124,750. Yep. Times 0.065 divided by 12. Okay, and so the monthly payment looks like it's going to be $842.32. Okay, and that's how much this family would be paying for the next 25 years. Okay, and that's again a closed-end credit problem. Now, the nice thing about this problem is that both the interest rate and term life of the loan are listed there. Okay, so here's 6.5% and 25 years. So I'm looking at 6.75207, and okay, here's that number, 6.75207 times the mortgage divided by 1,000, since this is the monthly payments to repay the principal and interest on a $1,000 mortgage. We don't have a $1,000 mortgage. Okay, we got $124,750 mortgage. If you were to type that into the calculator, you should get exactly the same thing. Okay. Now, so that's how much is going to be paid every single month for the next 25 years. Okay. Some of that's going to go to interest and some of it's going to go to principal. Okay. Since nothing is being said about compounding, I would assume simple interest. Okay. And by the way, you're going to assume simple interest for these problems here. So the interest, principal times rate times time. So the principal value is $124,750 times the rate is 0.065 times the time. This is 1 month out of 12 months in a year. T is always going to be 1 over 12. Okay. And if you were to type that into the calculator, you should get 675.73. Okay, so that's how much money out of this monthly payment is going to go towards interest. Now, the rest of this payment is going to go towards the principal. So, if I subtract those two amounts, then I get $166.59. That's how much is going to go towards the principal. Now, the balance of the principal is going to go down by this amount. Okay, this $166.59. So, what I do is I take the $124,750 minus $166.59, and I get this amount, $124,583.41. Okay, and so this is how much the family still has to owe left on the house. Okay, and so now month 2 comes, and they're going to make the same payment, $842.32. Okay, some of that money is going to go towards interest, and some of it's going to go towards principal. Okay, so to find out how much is going to go towards interest, again, assume simple interest. Now the principal is going to change here. Okay, it's going to be $124,583.41. That's the new balance that we had. Okay, so times 0.065 times 1 over 12, since this is one payment out of 12 months in a year. T is always going to be 1 over 12, by the way. And you end up getting $674.83. Okay, now the rest of the money is going to go towards the principal payment. Okay, so if I subtract these two amounts here, I end up getting $167.49. Okay, so that's how much in the second payment is going to go towards the principal. So like a whole $1 extra. Okay, so I subtract. I take the old balance minus how much I just put towards the principal, and I get $124,415.92 left. Okay, and then I continue this schedule for the next 25 years, and eventually it's going to be going down to $0. Okay, now what's going to happen is that the interest is going to get smaller and smaller, and the principal is going to get bigger and bigger. So anything that you can put above this amount, even if it's like $10 per month or something like that, is huge, okay, because it all goes towards the principal. Okay, and so that's huge because we looked at this is how much money A family's going to be paying typically, which is a lot of money. Okay, and so anything that you can do to knock this amount down is huge. Even if it's like $10 a month, that's huge. Okay, so the plan here is to have the balance of principal go down to zero, and the interest is going to go down while the principal payment goes up. Okay. You know what? I'm going to stop right there in the video, and we'll finish up the notes in the video in the next one.